Right, so we're given a 2 by 2 matrix here, 1/2 down below 1/3, 12 down below 8, and we're simply asked if this matrix, which we named A, is invertible. So to be invertible means that the inverse exists. So the question should be, in other words, i.e., in other words, does A inverse exist? So that's really what they're asking, does A inverse exist? But that's the same as saying, in other words, is the determinant of A equal to 0? Because you recall that if the determinant is equal to 0, then the inverse does not exist. Okay, so that's what we're going to check. We're going to check to see if the determinant is equal to 0. So let's write the determinant for A. The determinant for A is written as straight bars, like absolute value bars with the entries inside. 1/2 down below 1/3, 12 down below 8. And for this 2 by 2 matrix is found by doing the cross product minus the cross product. So it's 1/2 times 8, where we did this cross product and this diagonal, and then subtract, because that's the formula for the determinant of a 2 by 2, we do this diagonal, 1/3 times 12. Okay, let's calculate this. 1/2 of 8 is equal to 4. Bring down the minus sign, which is part of the formula. 1/3 times 12 is 4. Uh-oh, that equals 0. So what does that tell us? When the determinant is equal to 0, that means that if we plugged it into the formula for a 2 by 2, we would get 1 over 0, which is undefined. So the answer would be thus, the matrix capital A is not invertible. In other words, we're saying that the inverse, A inverse, does not exist. And we determined that by looking at the determinant of A and found that it was a 0. If it was anything but 0, then the determinant, the inverse would exist, and we would say that this matrix A is invertible. But since it's 0, the inverse does not exist.